Alright, so we're back for lesson 71. So for lesson 71, we're going to talk about trinomials again. So trinomials again, but when a is not equal to 1, okay? Or we're gonna actually make it 1. For this, we just say factor common factors and then you say before t-chart. Right, we made the t-chart in our supplement and in our lesson 68. Okay, so if we have an example 2 here, we have 4x3. Actually, it's actually 4bx3. So let's go back here. So it's 4bx3. And then it's minus 4bx squared. And that's minus 80 bx. Okay, so we will factor out common factors here first. Okay, so if we go back to factoring, remember, right, we're looking for things that are common in all of these. So there's a coefficient part and a variable part. So let's look again. So our coefficient, right, is our numbers here. Okay, and then our coefficient and then our variable part is right here. So now remember what we want to get, right? What do we want to get? We want to get ax squared plus bx plus c, right? Okay, so just a little reminder there. Okay, so now if we're going to factor out our coefficient, right, we can actually see that 4 would be our number part here. So 4, and then everything has b, right? Everything has b, everything has x. So we'd say 4bx, and if we took it out of this first one, then we'd end up with x squared. And we'd end up, if we took it out of the second one, we'd have minus, and we just have minus x, right? You see that, right? So if we took 4bx out of this, just minus x, then for this last one, we'd have minus 20, and we took a b and an x out of this. So now we're pretty much set to do our t-chart here, right? Because our a right here is going to be 1, our b is minus 1, and our c is minus 20. Okay, so if we want to put our multiplies 2, add the 2 hats on, right? Our multiplies 2 is AC, right? So it's minus 20. And then for this one, we have adds 2, we have minus 1. Okay, so if we think of a couple numbers here, if we did minus 10 and positive 2, those work to multiply to minus 20, but they're not going to work here, right? So we just say no, because we already checked that. Let's see if I can move my pencil over there. All right, so then if we think of a couple other numbers, right? One has to be positive, one has to be negative, but another one that I think of here is minus 5, and then we have 4. Right, so if we multiply those, then we're going to get to minus 20, and we're going to add there. So then we'll have 4bx still, and we'll have x plus our number, or both of our numbers, right? So x plus our number, right? So if we add that, we have minus 5, and then we have x plus 4. So there we did it. Okay, now if we want to do a different number, so if we had something like minus 3x squared. Actually, this is x cubed. Reading our example here. Okay, so this is example 4. So 3x cubed, and then I have minus 6x squared plus 72x. I'm going to go a little faster, but right, we'd say that we could factor out minus 3x. See, you can see that's the coefficient part. And then we have x squared. Then we have plus 2x. And then we have minus 24. Okay, so now if we set up our t-chart, we have multiplies 2, we have our adds 2. We have minus 24 here. Then we have our 2. Okay, so I think of minus 3 and 8. Those multiply to minus 24. They don't work over here, so I can put x or no. But then if I think a little bit longer here, if I had minus 4 and 6, those would definitely multiply to minus 24, and they work for positive 2 right there. So now I keep writing my minus 3x. It doesn't go away, right? I can just get rid of it. So then I have x minus 4, and I have x plus 6. Okay, so that's that right there. And then, right, to emphasize this, to check that I got the right answer, I can distribute, right? So I show it through my red pen again. I can multiply first by first, my outside by outside, my inside by inside, and my last by last. So I'll leave that as an exercise to you guys, and you guys can look for that in the book as well. Okay, so then for our last one, just say this is not a factoring, but for example 5 here, if we have subscripts, and I'll show you that in a minute. So subscripts says something like n sub n, right? So it might say something like that, n that. So subscripts do not impact procedures. Okay, it's just an unknown number, just like x, for example. So if I have example 5 here, I have nickels and I have dimes. So I'm going to say 5 times the number of nickels, okay, and then I have 10 for my number of dimes, and this is equal to $1.25. Okay, so that's my first example. So you can think of this one right here as just being x, and this one as being y, for example. Okay, so this is my first equation. Then my second equation here is n plus nd is equal to 16. Okay, so it's just telling me that I have 16 total coins, right? So I have 16 total coins here. So now I can solve by substitution or elimination here. So if I wanted to write my equation 2, I can say my number of nickels, and then, right, so if I did this, I skipped a step here, right, I'd subtract number of dimes from this side, and then I'd have 16 minus the number of dimes. Okay, so now that I solved for that part, now I can go on to the next part. So let's try to remember this when we go to our next step here. So if I move this over here, we have, okay, so we had 125 for a total, right? So we have um, 5 here, right? 5 times number of nickels plus 5 times our number of dimes is equal to 125. And then we had our equation here, I'm going to write at the bottom. We had number of nickels is equal to 16 dimes, right? That's what I said. So now we can substitute this up here, okay? So if I'm going to do that, I'll write 5, and then I can write 16 minus number of dimes, and write plus 5 ND equals 125. Okay, so now you can see in this equation, all I have to solve for is ND. So now I can multiply these across, or multiply these out, right? So I can use distribution. I can multiply this term by the first term and by the second term. So 5 times 16 would be 80. So I have 80 minus 5 ND and plus 5 ND. Let's see, did I write? I think I wrote something wrong in my practice here. Let's see. Oh, 10. Okay. Alright, you guys can see what happened here. Let's go back to my eraser. I wrote 10 here. Or I should have written 10 here, right? Because my dimes are worth 10 cents each. So we'll go back here, right? Our dimes are worth 10 cents. So this right here, right, is 10. So then this is 10. So we have plus 10 ND equal to 125. And you go back to the book and you can see this example as well, right? So then if I do this, then if I do minus 5 ND plus 5 ND, that gives me 5 ND. And then my number over here is actually is 80. If I want to get rid of something, I just subtract it, right? So I can get rid of it, and I'll do minus 80 on both sides. Now if I do that, then I have 45 for my number of dimes, or is equal to 5 ND. If I want to find ND, then I divide by 5 on both sides, right? Because any number divided by itself is always 1. So my 5's cancel, and then my ND is equal to 9. Okay, if I have 9 dimes, then I know over here, right? I underline this, right? My number of total coins is 16. So if my number of dimes is 9, then my number of nickels, right? So we can plug it back in. 16 minus 9, right, is equal to 7. Okay, so that's how you solve that. And like I said, these subscripts, the N, and D, they just stand for a missing number that we have. And they don't change any procedure or anything like that.